tutte le obiezioni, io sono Samuel. WW26.
European spaceport in French Guiana on the coast of the Amazon rainforest, and our rocket
Benvenuti, siamo live allo spazioporto europeo nella Guyana francese per il lancio di Biomass con un lanciatore Vega-C per il conto dell'Agenzia Spaziale Europea. Biomass studierà le foreste del pianeta tramite un incredibile radar che penetra le chiome degli alberi e siamo a 15 chilometri dal centro di controllo e io sono con Samuel Rogez. Samuel di
Thanks so much for being with us, Samuel.
Thank you, Katie. Great to be here. Hi, all.
And if you want to ask a question and you're watching on YouTube, you can pop it into the chat box and Samuel will do his best to answer it later in the programme.
Correct.
Right, now let's go inside the control room to find out how operations are progressing. And the head of the flight desk is David Cavalloles, the CEO of Arianespace. Thanks for being with us, David.
Hi, Katie. Good to be here with you today.
David, Arianespace is operating the launch. So I just wonder, what does that actually mean?
Well, it's very simple. It means that we are responsible from the beginning to the end of making that launch happen. So concretely, it implies that we are working very closely with the client, hand in hand, to prepare the mission, typically to define together the best injection strategy for the satellite. Here in Kourou, we perform very important operations to prepare the satellite and to integrate it into the launcher. And of course, last but not least, we are accountable for the launch itself.
And how are things progressing today in the countdown?
Well, overall, the campaign went very smoothly, and I would like to thank the team sincerely for that. One of the key last milestone has been the rollback of the mobile gantry that protected the rocket, the Vega-C rocket. So now Vega-C is on its launch pad, ready for liftoff, and the launch should happen now less than 20 minutes from now.
Good to hear, and everything's green so far, so good. David, it's an important mission, isn't it? Can you tell us a little bit more about it?
Yeah, for sure. This is indeed a very important mission. The satellite we are launching today is called Biomass. This is a mission for the European Space Agency, which is our client today. And Biomass carries on board a very innovative payload, a radar that will watch the forest all around the world. And it will provide very useful data about the carbon cycle. It will be very useful for our scientists, very useful for our decision makers as well. And through this mission, we'll contribute to fight against climate change and also to protect biodiversity. So for this reason, I'm extremely proud in the name of Arianespace to be launching Biomass today.
Great. Thank you very much indeed, David, and best of luck to you and all the teams. David Cavalloles, thank you.
Thank you.
Now, Vega-C and Biomass are due to lift off in just over 15 minutes' time. Samuel, what's going to happen after that?
Yeah, so as you said, the liftoff will be triggered by the ignition of the first stage, which we call P120, the first stage of Vega-C. It will push for about 2 minutes and 25 seconds, and then a separation command will be sent to separate it. It will then be followed by the ignition of the second stage, the Zefiro 40, which will continue increasing the launcher speed for about 2 minutes. Then this stage will be separated as well, and it will be the Zefiro 9, the third stage, that will take the relay and provide the launcher thrust. Zefiro 9 will push for 2.5 minutes, and during this phase we'll separate the fairing, which was protecting the satellite as we went through the atmosphere. Then Zefiro 9 stage will be separated, and we'll have another important step, the ignition of the upper stage, the Avum Plus, which is a bit different because it uses liquid propellants. After 7.5 minutes, we will shut it down, and then we'll have what we call a ballistic phase, a long phase over the North Pole, and then back down to Australia, where we'll be in contact with a ground station in New Norcia to perform the second ignition of the upper stage. And as we have reached the final required orbit, we will be ready to separate our passenger today, Biomass. Then we'll have another ballistic phase over the South Pole before reaching the last step of this VV26 mission, which will be the third ignition of the upper stage over Cuba, this is necessary to make the upper stage re-entry, and this is very key to avoid leaving any debris orbiting the Earth.
Meanwhile, biomass will be coming alive, ready to start its job. And what an important job it is. It's going to scan the tropical forests just like a doctor to help scientists understand what state they're in and their role in the carbon cycle. And to do that, it has a very pioneering radar which can see right down inside even the thickest of forests to analyse the trunks, the branches and the large shoots, which is where the trees store their carbon. It's going to help us to understand our forests. It's very important. Let's take a closer look. As a system and how people are affecting natural processes is more urgent than ever. And biomass is the 7th satellite in the European Space Agency's Earth Explorer science program to do just that.
Yes, indeed. And in fact, the Earth Explorer satellites actually collect information about all the complex processes of our planet. We can have several examples, typically the motions of the winds or the tides, or measure the thickness of the polar ice caps, or monitor the magnetic field of the Earth. These are typical examples of the missions they are carrying.
And many more. Very, very important program. Just back to our launch, we've had our final weather check. That was at T-10.
Yes, indeed, and the news were good. Actually, we had another check before the removal of the mobile gantry, which we see on the screen just behind the rocket. It was 4 hours before the liftoff to check that everything was fine before removing it. And the last weather check, as you mentioned, was 1 minute ago, and the news were good. So all is fine for lifting off.
Looks like we have a slightly cloudy sky here, but the weather's actually been rather nice these last few days. We've had a bit of sunshine. I can see there on the image the clouds might just part for us for a beautiful launch and, of course, sunrise. The European Space Agency teams who will be operating biomass are standing by in the mission control room at the European Space Operations Centre in Darmstadt in Germany. Just over an hour ago, the Flight Operations Director, Jose Morales, took the roll call.
All positions on the briefing loop. This is the biomass roll call. All positions shall report on this loop to me by quoting your call sign followed by go or no go. Some go. AOCS.
AOCS go.
Data handling.
Data handling go.
Power.
Power go.
Spacon.
Spacon go.
Timeline.
Timeline go.
Project rep.
Project rep go.
PST lead. Software coordinator. Software go. Software support.
Software support go.
Flight dynamics.
Flight dynamics go.
OM.
OM go.
S-track.
S-track go.
Scheduling.
Scheduling go.
Excellent. This completes the biomass roll call.
Excellent. So they are go for launch. We are go for launch. The boards are green and we are 6 minutes and 56 seconds and counting to liftoff. We'll check in again with the ESOC teams after launch, and especially when biomass will send its first signal home to spacecraft controllers. Back here at the Guiana Space Centre, we've got several control rooms. Obviously, this is mission control, but we've got another control room, Samuel. It's launch control, we call it.
Yeah, Launch Control Center. It's if we compare the rocket with an airplane, then the Launch Control Center is a bit like the cockpit of this airplane or the rocket, if you wish. So, and here we can see the team on the screen. They are in charge of preparing the rocket for the last step, checking the parameters, overseeing all these final operations to get the rocket ready for the launch. And of course, once the liftoff will be triggered, the rocket is fully autonomous. It goes autopilot after the liftoff. And in fact, you have two teams. The first one we saw are actually running the operations, and the one behind are checking that the actual parameters are in line with the expectations and checking if any deviation, then analyzing the situation.
Laser focus at this point as we get closer and closer now to the launch. Vega-C standing tall on its pad. Now, everyone also has their eyes on the status panels. We saw them earlier here in the Mission Control Center, the green panels. There they are on the left-hand side of the screen there.
Yeah.
All green at the moment, good sign.
It's a bit like the traffic lights. If it's green, we can go ahead. If it's red, of course, we'd better stop and analyze. And each of these panels actually corresponds to a person, a team operating or monitoring that system. Could be, for instance, one for the rocket, of course, checking for instance, the tank's pressure or temperatures on board, the status of the onboard computer. Of course, we check also the communication links, the weather status, as we mentioned before, but for sure also the passenger biomass which has its own status panel, which is on the screen. And of course, if something goes wrong, if there is any parameter that deviates from what should be the nominal value, then we notify the range operation manager, and we can hold the countdown time needed to analyze the situation and then assess what the next step should be.
Coming up now to the beginning of what we call the automatic sequence or the synchronized sequence. That's the last 4 minutes. Coming up, just briefly, Samuel, what is that?
À tous de DDO. Attention pour la séquence finale lanceur.
Range Operations Manager Jean-Frédéric Alassa today, getting ready to announce it.
Top H0 4 minutes.
So what is the synchronized sequence?
During this sequence, in fact, the rocket is becoming progressively autonomous. So currently the computer are managing an impressive sequence of complex operations, each of them timed to the millisecond to get progressively the full autonomy to the launcher.
Now, the job of preparing the rocket and the spacecraft here at the spaceport started a couple of months ago. We call this process the launch campaign, and the teams have been working extremely hard during that time to get everything ready for today. Our cameras were there. Samuel, what's been happening?
So first, most of the parts of
out to launch, hoping for a very beautiful dawn launch. Getting close, quite tense at this moment before launch, isn't it?
Yeah, we can clearly feel the intensity, the concentration. All the teams are focused on their task.
À tous de DDO. Attention pour moins 1 minute.
Coming up to 1 minute now to launch.
Top H0 moins 1 minute.
We are live at the European Spaceport in French Guiana, getting ready now for the launch of Biomass for the European Space Agency. Good luck, everybody.
Good luck.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage P120. Décollage. Propulseur nominal. Début du basculement. Propulseur nominal. Pilotage calme. Trajectoire nominale. Acquisition Saint-Jean. Trajectoire toujours nominale.
sunrise over the Amazon rainforest, and biomass has started its journey, blazing a trail on
La
board the
trajectoire est
Vega-C
nominale, le
rocket
pilotage est calme.
on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying over the...
Amazing pictures, and yeah, we can feel the the walls
shaking here at the Jupiter Mission Control
Trajectoire
Centre.
nominale.
He's telling us that everything is going well.
Yeah, so far it's perfect. We are lucky to see it so long. It's given the clouds we had at the beginning.
Getting some great views here from our cameras. Burning the P120 first stage here, which is getting us away from the
La trajectoire est nominale, le pilotage est calme.
The gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting.
Yeah, control of the thrust, the orientation of the thrust as well. So it's nominal means everything's fine.
Good. Coming up
Début côte poussée.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic views.
Potentially we could see it from the cameras. It could be nice, yeah. Should occur in a few seconds now.
Indeed, this is the scheduled moment for the
And you can
separation.
see it on
Séparation P120.
and it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120,
nominale.
the
La
first
trajectoire est nominale.
stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for, yeah, Zephyro, it's an Italian name for a type of wind. Because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Guiana Space Centre.
Amazing, yeah. Wow.
We had several weeks of rain, and suddenly it's been very clear
La
and beautiful.
trajectoire du lanceur est nominale.
He's telling us that the trajectory of the rocket is normal.
It's perfectly as planned. Yeah.
And of course, the fairing, which is where our satellite is encapsulated at this point, Samuel, is the nose cone, if you like. We saw it before
La
the launch.
trajectoire est nominale. Le pilotage est calme.
And
It has a multiple...
it's got a number of jobs, hasn't it?
Yeah, exactly. Yeah. It basically protects biomass from a number of environments. First, of course, the Guiana environment, the rain and the dust, everything. But also at liftoff, we have, when we fire the booster, there is quite a high acoustic vibration environment. Then the fairing is used to damp it, and as well to...
Trajectoire nominale, pilotage calme.
As we go through the atmosphere, it helps reducing the heat loads generated by the friction with the atmosphere or the vibration. So it's quite a clever piece of hardware, yeah.
Very important. You can see it at the front of the rocket there, the sort of bulbous section. Right, we have now the scheduled moment to separate the Z40, to jettison that.
Séparation Z40.
That's
So it's
been...
just confirmation that the Zephyro 40 stage has been separated.
And
Allumage Z9.
And
we've switched on the engine of the Z9, and we've also waiting for
Propulseur
confirmation
nominal.
of the fairing jettisoning.
Séparation des coiffes.
And we have confirmation.
it. Yeah.
So we can see our satellite for the first time, Samuel. Why don't you explain to people what we're looking at here on these computer-generated images?
Yeah, on the left of the screen, you can see first on the right,
Trajectoire
biomass
nominale.
passenger with, of course, its radar and solar panel folded. It's attached to what remains of the launcher, which is rather small as compared to what was on the pad, through the adapter, this black cone, and then you have the upper stage, which is a tiny, a slice, a white slice of the launcher, and on the
La
left,
trajectoire du lanceur est nominale.
the Zephyro 9 stage, which is still thrusting our passenger into space.
And of course, once biomass is separated from the mothership, it'll unfold its solar wing. It has one solar wing made up of 4 solar panels. And of course, it's amazing, great big reflector, which looks like a huge space umbrella.
Yeah.
So quickly, let's just explain to people what we're looking at on the screen. So we've got the 3D images, which are computer generated.
Yeah, and they correspond to the plan.
La pression chambre est nominale, la trajectoire est nominale.
It illustrates what the launcher plus biomass behavior should be in space, the orientation towards the sun or towards the Earth, for instance. Of course, the altitude, the different stages separation, as we saw, and of course the real orientation and firing, as we see here.
You can see on the left side of the screen are the various events that as they happen, and then on the right-hand side of the screen the trajectory, and we also have the altitude. At the moment we're 663 kilometers high.
Nominale,
263. Yeah.
Sorry, it's 263.
Yeah.
We will be getting closer to 600 later.
Not yet.
And our distance is our distance from the pad. If you were to draw a straight line across our planet, and look at that speed, we are travelling, Samuel, at 7.53 kilometers per second.
This is quite fast. Yeah. This is roughly 8 kilometers per second. Just for people to have an idea, is 30 times the velocity of a commercial aircraft. So it's fast.
Z9 confirmé.
About 28,000 miles per kilometers per second.
Per hour. And here we had just confirmation of the separation of the third stage, the 409.
Indeed. And
Acquisition de la télémesure par la station Bermude.
There he's announcing that we're picking up the signal at the Bermuda tracking station, which you can see there on the globe. Bermuda, of course, in the northern Caribbean.
Orbite du Z9, correct.
I'm sure it's all very sunny as the sun rises there. Very pleasant weather, I'm sure. Checking in there at Bermuda and saying hello to the teams. So our flight path takes us, north, up over the North Pole?
Exactly, yeah. We'll fly after the Canada, we'll fly over the Arctic, and then back down over Southeast Asia and to the west coast of Australia, where we will separate biomass.
Début de la manœuvre d'orientation pour le premier boost à Vom.
So he's saying we are orienting doing a set of maneuvers to orient correctly the launcher to fire the upstage Avon Plus, which should occur in a second or two.
Allumage de la Vom.
So we have confirmation that the Avon Plus upper stage has switched its engine on, and that's an important moment, an important milestone. We've really now started the next phase of the journey, because the Avon Plus is a little bit like our orbital taxi driver. Its job is to deliver our passenger to its drop-off point in space, and that's a very important job.
Yes, indeed, and it's the Avon Plus job, as you said, to deliver biomass exactly on the right orbit, in the correct orientation, and to do that we need to perform with this upper stage precise set of maneuvers, and we'll see two firings. This is the first firing, and we'll have another one later in the mission, and this will enable to reach the separation orbit, which is circular at 670 kilometer altitude in about 49 minutes.
Fin de visibilité Galio. Trajectoire nominale, propulsion nominale.
So we've gone out of the range of the Galileo tracking station. That was the tracking station here at the spaceport, and everything's going well. Big space projects like biomass involve hundreds, sometimes thousands of people pulling together to make them happen. They involve brain power, teamwork, lots of problem-solving skills.
And potentially lots of coffee cups as well, or tea.
Lots of cups of tea in this case, yes, because biomass has been designed, built and tested by the European aerospace giant Airbus Defence and Space, and a lot of that's been done in the UK.
And they are what we call prime contractor, so it's like they are conductor of an orchestra.
Propulsion nominale de la Vom, pilotage calme.
It means they manage a group of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware for biomass. And in particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
In fact, I was lucky enough to see it because I was filming there a little while back, and it was really exciting to see biomass in the clean rooms taking shape. Big shout out actually to my fellow compatriots in the UK, Airbus in Stevenage. So let's just check where we are in the flight. We are climbing.
Close to 300 kilometer altitude and 3,000 kilometers.
La trajectoire de la VOM est nominale.
So trajectory is perfectly on the target. We are running gently the propulsion of the Avon Plus, consuming propellants.
And we're coming closer now to picking up the signal at the Gatineau tracking station. You can see it there in Canada, the northeastern coast of Canada.
Acquisition de la télémesure par la station Gatineau.
He's just confirmed that we've picked up the signal there. It's a bit like a relay race, isn't
Exactly,
it?
yeah.
Handing the baton from one tracking station to another.
Yeah, we want to be sure to have contact with the launcher during this phase while propulsion is active to receive the parameters.
Pression nominale des réservoirs, le pilotage est calme, la trajectoire est nominale.
Everything's going normally. So the rocket's talking to us, it's sending its signal back down to the tracking stations, and they then transfer that information to the telemetry team here at the spaceport. We call them the CVI in French, or the Quick Look Telemetry Team. And we can see them actually in the bottom right of the screen there. Our colleagues, your colleagues there, Samuel, they're on a hilltop, aren't they, just outside the spaceport?
Yeah, very close to the spaceport on La Montagne des Pères. And they are actually, as you said, receiving the major flight parameters from the launcher
nominale de la VOM.
all along the flight, thanks to these antennas which are located on the
Il reste 3 minutes de propulsion de la VOM.
On the path. And it's a bit like the doctors who are checking the health, monitoring what's happening on board, checking everything's fine, as expected. And you can see here my colleagues Michael Krepel, who is in charge of the team, and also Armel Giral, together with Avio and CNES colleagues. And this is, as we said, possible thanks to the different ground tracking stations located first were in French Guiana, then in Bermuda, then in Canada, and last one will be in Australia, as we mentioned.
Now, one of the features of the Avon Plus upper stage is that it can restart its engine again and again. We have another team here in the Colleferro in Italy.
Yeah, indeed. There are teams from Avio, the rocket manufacturer, and they are checking from Italy that the launcher behavior is fine, analyzing the data.
Pas d'écart en altitude, trajectoire nominale.
There are people from different teams, such as propulsion, structure, control,
Le lanceur est mis sur orbite.
And they are available and ready to jump if needed as a support team, so it's very useful.
And indeed, as you say, they are the manufacturers of the rockets, so it's very useful to have them there and to have as many people on the job as possible. Indeed, as I was saying, one of the features of the upper stage is that it can switch its engine on and off, and that's actually very important. Why is that?
Yeah, it's very key because it's a major asset of this upper stage, because it makes possible to take different passengers, like you say, like
altitude, la trajectoire est nominale.
Like a space bus, to put different passengers to different orbits, but in the same launch. So this is really key, and with this upper stage Avon Plus, we can fire it up to 8 times, and this is much more than the previous 5 on the little sister Vega, and so it's very helpful to deliver several satellites on typically 3 different orbits we can reach with Vega-C.
1 minute de propulsion de la VOM.
On the same
la
mission.
La propulsion est nominale, trajectoire nominale.
So it's really a key asset for our customers indeed.
And it means that you can take pretty well any satellite to any orbit, and that's very important, that level of flexibility.
Yeah.
And we're getting ready now, the Avon upper stage is getting ready to switch off its engine. How does it know when to switch it off?
In fact, this is based on its initial position, which we feed the launcher with on the pad, and then it has clever instruments along the flight, computing where it is and how it's oriented, what's its velocity all along the flight.
Propulsion nominale, pilotage calme.
It knows precisely where it is and when to stop it, and which should occur soon.
We are 3 129
Fin de la
kilometers
visibilité par la station Bermude.
above our planet. We have now gone out of range of the Bermuda tracking station, and we're being tracked by Gatineau, getting ready to switch the engine off.
Propulsion
Waiting
nominale, pilotage calme.
for the confirmation
Extinction
there.
de l'étage avant.
And we have the switch off of the upper stage engine now confirmed, so that's really good. Why now? Why do we switch it off now?
Par l'étage avant correct.
So it's just saying that when we stopped the engine, as I was saying, we were exactly on the point we wanted to be. So this is really good news. And why do we stop it? We stop it because we are climbing to just below 700 kilometers, and we'll do it in 2 steps. So here, this is the first step, and we have reached the target.
La pression des réservoirs est nominale.
So we just stop it, and it's all very normal as planned.
Now, today's launch is the result of years of collaboration across many, many teams, and we've been talking to some of them. Let's hear from them now. Now, once the upper stage delivers biomass onto its orbit, the teams at the European Space Operations Centre, which is in Darmstadt in Germany, will take charge of flying their satellite.
Yeah, and first biomass should call home, then it will unfold its solar wing and start all the process of being tested before actually it can begin its job of scanning our forests, which should start in 6 months from now.
Indeed. And the teams at ESOC operate all the European Space Agency's satellites. That's more than 90 of them over the years. And they also take care of ESA's network of tracking stations. They provide world-class expertise for flight dynamics and mission operations. And it's also home to ESA's space safety program. So it's a busy old place. Thomas Ormiston is a spacecraft operations engineer, part of the team flying the satellite. So he's one of the people in charge of flying biomass today. Let's go to Thomas now.
And hello, welcome to Mission Control here in Darmstadt, Germany, where the team are calm, sitting back, enjoying the ride for the time being as we carry on the journey of biomass to space. They're all getting ready for that moment we're hoping for a bit later on, where we'll pick up the signal. But for now, we can enjoy standing here, and I'm here very happy to be joined by biomass mission scientist Bjorn Roman, who's going to tell us a little bit more about what biomass is going to do. So thank you, Bjorn, for being here. It's your baby. How are you feeling having seen that spectacular sight?
Yeah, spectacular launch, Thomas. It was great to see it from here. We're also joined here by a lot of people from the science team. We've been waiting for this for years, and of course waiting now for the spectacular things that are to come after the launch.
Absolutely, and I saw the emotions on people. It's quite a moment here, and there's still more moments to come. Now, tell us a bit more about this. One of the key goals of biomass is to study the role that forest biomass plays in the carbon cycle. How is the data from the mission going to help fill in humanity's understanding of this?
Yes, Thomas. A very good question. The main science question of the biomass mission is really to try to unravel the main unknowns that we have in the global carbon cycle. As people know, most of the actual CO2 emissions that are going up in the atmosphere are coming from the burning of fossil fuels, but the remaining part is coming from land use change, and most of it can be attributed to deforestation. And this is and on the other side, there's of course as well then the actual sinks. About half of it, what we're actually emitting, remains in the atmosphere. About 3/10 is going back into the forests. So this is actually a very good thing. This is actually one of the few things where forests are known for, is that actually there's a very natural way of capturing carbon. And actually the forests are growing from it, so it's actually a very, very nice thing. The remaining part is going into the ocean, and for the oceans actually it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the biomass mission will especially look at the tropical forests, and this is exactly the areas where the largest unknown, so we have a gap in our knowledge. And on top of this, there's also the place where we know the largest changes are occurring.
Yeah, exactly. And I mean, when we're looking at those things, I mean, we've had radar missions from ESA before. These are studied in other ways. I mean, what is it about biomass's radar that makes the technology so unique and so special for this?
Yes, I can tell you about this, Thomas. So as you mentioned, ESA has been flying radar missions before, and the type of mission that we're flying, type of technology, synthetic aperture radar, we're flying this actually already since 1991, ever since the launch of ERS-1. So SAR is not new to us, but what is new to us is especially the frequency that we're flying. We're flying for now with biomass. We're flying the lowest frequency used for Earth observation for radar imaging ever used by mankind. So this is a really unique, and with this wavelength, we're able to actually penetrate down to actually the forest and down to all types of natural media, which would give us additional new information, complete new information on our planet. And in the forest, we're able to we're actually sensitive to the larger structures that we see in the forest. So think about the branches and the stems, and this way we can get, let's say, really new information that we can then later on relate to forest biomass and forest height.
Excellent, amazing. And I mean, I understand these forest ecosystems are incredibly diverse and varied. I mean, biomass, I think, will allow scientists to differentiate between the different types of forest to measure the biomass. I mean, how's it going to do that?
Yes, this is a very intricate process with a lot of very interesting algorithms that we're going to do. The first thing, of course, we get the data from the satellite, and with this, we hope to be able to estimate biomass, but as well forest height. Together with these two, we hope to be able to constrain our solution space in the end. What we have on top of this with biomass is that we have a very exciting first operational phase of the mission where we employ tomography. And it's actually the first time where we systematically employ this type of operations during a mission. And with the tomography, which you can compare like with a CT scan when you have to go to hospital. Hopefully you will never have to see this type of device, but it's able, let's say, to slice 3D slices of the human body. And we're doing something similar in the forest. So we get information on the 3D structure in the forest, so we get a 3D view on what is happening there. And with this, we hope to get as well additional structural information that we can relate to different forest species, different forest biomes.
Wow. Really fascinating. And I mean, yes, so biomass is one of our Earth Explorers. The Earth Explorers all have a topic, and biomass is focused very much on forests. But are there other areas you expect this mission to contribute to?
Yes, for sure. We're actually counting on it. This will be, as I mentioned, is the first time we're going to fly P-band, this 435 megahertz frequency. And with this, of course, we're going to basically, for the first time, look at our planet with what I call P-band goggles. So we really are going to unravel completely new things about our planet. And this is always when you fly something new with a new wavelength, you will see completely new things. But we have already identified a few areas for which we know there's a good chance that we can do some real nice new science. One of them is looking at the forest floor. As I already mentioned, that we're going down with a signal, we're able to penetrate down to the entire forest layer. And we're actually also sensitive to information that we get from the forest floor. Now, with other systems, we always get to say out of the top of the canopy a bit, but we never can create, let's say, a digital terrain model from the forest floor. And about 30% of the land is covered by forest. So all the DTMs that we have, the terrain models and the digital elevation models, they have a kind of an unknown area. They are not able to precise accurately what actually topography is doing there. So this is something that we hope the mission will also be able to contribute to. A second one is we're looking at ice in the Antarctic, the land ice in the Antarctic, and how it is actually moving. So there are other missions that are doing the same thing, but because again about our penetration into the ice, we'll be able to get access to additional volume scattering that hopefully is going to be stable over time to be able to follow this as well, in addition as well to ice structural information. Then another one that's also very exciting is actually that we're able to look at the deserts and look at paleohydrology. So looking at ancient rivers been dried up, and maybe some remains of ancient civilization that were living in deserts at the time they were not deserts. So this will be, and of course, Thomas, this is not everything. They're going to be for sure, as I said, looking with P-band at the planet, we're going to be in for some surprises there.
Wow. I mean, really, really exciting stuff. And yeah, I think we can all be very, very excited about the science surprises. I would say, though, as an operations person here in this room, we don't like surprises. We hope everything goes according to plan. So far, indeed, everything is good. You can see on the board behind me that we're all green. ESOC is very much ready to take control of the spacecraft when it separates not long from now from the upper stage of that Vega-C launcher. But for now, I would like to say thank you very much to our launcher for giving us a gentle ride. We will continue enjoying it here in the control room, and we will be back to talk to you later once we've separated to catch that all-important moment of first acquisition of signal. Thank you very much. Back to Katie.
Thank you so much, Thomas and Bjorn. So great to hear from you both and have such a fantastic description of this terribly, terribly important satellite. Okay, so we're going to take a break now because we're coasting without the engine. So we're going to cut our mics for 20 minutes. We're coming back at 7:05 Kourou time. That's 11:05 here in UCT, Universal Time, 12:05 in Paris. And if anyone wants to ask a question,
put them in the chat.
Yeah, put them in the chat box on YouTube or any of the social media. I think you'll do your best to answer later. Okay, see you in 20 minutes. Bye.
Goodbye.